Hello everybody. Today we are solving another probability question that has the following probability distribution. For every x equal to k, the probability is given as b into k p raised to k minus 1, where k is all positive integers and probability is something, a value that ranges between 0 and 1. Um, and we need to like solve following questions related to that. So the first question is find b so that p of x equal to k represents a probability mass function. So some information that we need to solve that is a valid probability mass function has sum of all values 0. So if we like take p of x equal to 0 equal to b into like 0, this would be 0. So if we like put all the values of k in the formula p equal to x, p x equal to k, uh, and then sum it, we should get 0. So for like sum of all the values from k to infinity, we should get some 1. We also know that like this formula can be like this summation can also be denoted by what we have written above, that is b into k um, into p raised to k minus 1, uh, k minus 1. Oh yeah. So where again like this summation, in this summation we put all the valid values of k, and like this should be equal to 1, right? But another thing that we know is that whatever happens, this value b is always going to be constant. So I would suggest like watching a few videos regarding similar questions and why the value would be similar. So one intuition for that is like same. An intuition for that is the value b is generally the reciprocal of whatever the remaining value all the other variables or constants in the equation make. Uh, and the reason for that is the summation of the entire thing is 1. So b should be reciprocal of whatever the remaining value is for it to make 1, for it to be equal to 1, right? Uh, I mean, a few simpler examples would make it clear to you. Uh, so yeah. So we can write this in this way. So like we can write it like k equal to 1 infinity. And if we take b to the right hand side, it would be equal to k into p raised to k minus 1 equal to 1 by b. Now, does this make sense? I hope it does. And if it like makes sense to you, then it's like we have solved the question almost. So we know that we also know that uh, like the differentiation of p raised to k, right? The differentiation of p raised to k with respect to dp can be written as k p raised to k minus 1. And if you see that this is just this value, right? So that that means that like if we write it like this, uh, it makes sense, right? So dp raised to k dp, which is like this value, we are just like substituting this value. So this would be equal to, hope it makes sense, and I hope my handwriting is readable. So yeah, it becomes this. And um, there's also a property of differentiation which can be used here, that the sum of the sum of derivatives is equal to derivative of sum. So using that, we can like write this as we can write this as um, something like this. Oops. Yeah. Now we can write this as something like this. And what we'll do is we differentiate. Uh, since yeah, before differentiating, you see that since P of k is like between 0 and 1, right? The values of P is between 0 and 1. So we can like take the sum of this, an infinite sum of this, which is given by formula. So like this formula for infinite sum is uh, in a series that is converging, that is like the number is between um, 0 and 1. So we can sorry, a and r is like between 0 and 1. So this can be written as 1 minus r. So using this formula, we write this as p by 1 minus p, since like it grows by p every time and a is equal to p, right? I hope that's clear. If that's clear, then we have the equation finally as, oh, we have this, so no need to like include summation. So the summation is equal to this, and the differentiation of x by 1 minus x, or p by 1 minus p, is where's my pen? Oh yeah, here it is. So this would be this is equal to you can use the u by x rule, or you can use like substitution. Any of that works, and it comes out to be 1 minus p. I use Wolfram alpha, so it comes out to be something like this. And we have b on this side. Let's not forget that. So like this has been the LHS so far, and we will still have our RHS from here. So our RHS is 1 by b. So our b is 1 minus p whole square. I hope this was clear. Um, if you did not understand anything, let me know in the comments and I'll be happy to explain it to you. Um, let's move on to the second part of this question. Uh, so we have now solved the question for the value of, I'll just write the answer first. Okay. So the answer for 1A, so part A is B equals 1 minus B raised to 2. Yeah, and I'll put the answer here. So let's keep track of answers as well. Yeah. So the next question is find the expected value of x. And since we have found the value of b, we can like continue to use it. Why not? So our new function that we have is like we can say that p of x equal to k is 1 minus p whole square into k into p raised to k minus 1, right? By substituting the value of b, of course. Uh, so let's start solving the second problem. Yeah. So expected value. So what is the formula of expected value? So the formula for expected value is x, like if x equals like expected x into um like it is, I think, summation of xi into p of x equal to xi, okay, for any xi, okay, which is obviously the part of x, so basically x. um I hope what I said was clear. If that was, then we can like move ahead. um so I'll just write it for like your understanding in a easier to understand text. Some, I mean, handwriting. Uh, uh, yeah. So this, I'll just. So like this is how like expectation is written. I'll remove the shitty version of what I had written. I don't know how to remove it. Oh, why? Oh, sorry for the delay. Yeah. So let's proceed with it. Yeah. So this expectation is basically from k to 1 to infinity into k. So our x in this case would be k, right? And p of x equal to x is what we have from here, uh, here, and we already have the a value of b, so why not just put it there? So this would be 1 minus p whole square into p of k minus 1. I hope this is clear to you. So yeah, and I think we missed another k that we had here from here, obviously. So yeah, this becomes summation of k is equal to 1 to infinity to k square 1 minus p whole square p raised to k minus 1. Is that clear? I hope it is. Yeah. So moving on, we have I mean, I used Wolfram's calculator to solve this. So like if you put this, obviously we need to remember that p is between 0 and 1. So this can be like calculated using a formula, which gives you, I think it gives uh, you the answer in this form. So yeah, I like used Wolfram, and personally, like I don't know how to solve this. So maybe if you know, let me know down in the comments. I would appreciate the explanation for this. So uh, we have calculated the second part of this question, and we have our e of x, which is we have our e of x as uh what did I just write? 1 plus p by 1 minus p. Oh, sorry, by yeah 1 minus p. So yeah, we have our expected value as this, expectation of x as this. Uh, let's move on to the second question then. So we need to find expectation of x square. So In this case, all the values of k would become k square. So I don't know why I deleted that. That would have been like, yeah, faster. So this would be, I'll write it in a good handwriting to begin with. In that case, it will save me some time. Oh yeah, so it would be x raised to 2 into p of, yeah, right. And yeah, of course, not to forget the summation. So it can be written like this. Um, so expectation of x squared is summation of x raised to 2 into p raised to x is equal to x. Yep. And well, like we can just like write this in a formula form and maybe like try to solve it. So this can be written as k is equal to 1 to infinity. This x becomes k square, and we have the value like p of x equal to x is represented by again this formula, and we have the value of b already. So like we all skip all that steps and just write. Uh, I think we have another k here. Uh, and the final one is this, right? So yeah, so this will become a cube and 1 minus p square and p raised to, yeah, which in turn is again I use Wolfram alpha for this, and we can get direct answer for this. Uh, remember to put uh, p is less than 1, like between 0 and 1 to uh, make sure that series is convergent. So this is what we get. So the expectation value of e raised to x square is p square plus 4p plus 1 by p minus 1 whole square. I hope this was clear to you. Um, I'll just clear this. Oops, oops. Yep. Mm. Yeah. So yeah, we are done. We are done. Just give me a few more moments. Yeah. So this is the answer to part C. Let's begin solving part D. So part D is relatively simple. We already have the value of e raised to x square. Sorry, yeah, we have the value of e raised to x. So we can just square it, and that would be e raised to x, uh, e square x, and we have the value of e raised to x square. So uh, if you want, I can solve it. Yeah, so like I'll just solve it. So part D, e raised to x. So from this, we have e raised to x as 1 plus p by 1 minus p. Whole, don't forget the brackets, they are important. So e raised to x square would be square of this. And we just found out e raised to x square. This is p square plus 4p plus 1 by p minus 1 whole square. Uh, and on subtracting both of them, um, square minus e raised to x is equal to 2p by let me see what I got. Yeah, yeah, it would be equal to this. So uh I think this was like relatively simple if you manage to solve the first two. So yeah, let's move on to the next question. Delete. So let's do the final one. So part E. Um, so how do we go on to solve this? So we are given that probability. So p value is equal to 1 by 3, and we need to find the conditional probability mass function. Given p of like we have to find like p of x equal to k, given x is between 2 and 5. So this is a like good opportunity to use like conditional probability, uh, which is like which is p a given b is probability that a will happen, probability a intersection b given probability of b. So if you know this formula, then we can like uh, move ahead and try to solve the question. So using this, we can write this in the form p of x equal to k by 2x equal to p of x equal to k intersection 2x. So I have just like used the formula and written it in this form. Like I haven't like solved anything, just written like this using the formula. And if you see this, this is um like uh, uh so yeah, this is given by uh k equals to 2 to 5, and yeah, which is if you put the formulas like whatever we have calculated so far, so we have the value of p is equal to 1 by 3, 1 minus p square, which is the value of b. So this is b, and if you put the value of p here, it becomes 4 by 9. So hence we get this 4 by 9, and uh, then we have our k. So k I think stays on. Then we have value of p as this raised to k minus 1, and where k is like between 2 to 5. So like on solving this, again, I use Wolfram alpha to solve it directly. The value comes out to be 0.5377. So uh, I mean, for the sake of cleanliness, like writing this as um just for the sake of cleanliness. And for like ease of solving, this can be written as 0.5377. Was that the value that we got? Yeah. So, and we also know that that x equal to k. Uh, so what does this mean? So this means that p of x equal to k will be only valid for k values equal to 2, 3, 4, and 5. So only this values will be valid. And for rest other values, this function becomes invalid. So we can write it as probability at x equal to k, given for all k equals to 3, 4, 5, right? And this can be again written by this formula, and we have all the values, so we'll like skip the calculation there. E77 again for all values k equal to 2, 3, 4, and 5. I hope this was clear. And if you understood and learned something from this video, please throw in a like and subscribe to my channel and stay tuned for more. Thank you.